Welcome back, guys. We are talking about abstraction today. This video lecture is going to be very interesting, I can tell you, because abstraction is something you will enjoy in real life also. So, it is something that is not required to be hidden. Okay. So, abstraction, you can say, is to hide something you don't require. And you have seen it all around you, like you watch television without even bothering to know how the signals are transmitted, received, and how do you get the images, the videos on your television, right? You don't bother. Now, if you look at the nature, and nature has also hidden things from us. It is very interesting to see that we human don't know what is going inside us, right? And suppose if our skin was transparent or translucent, or you can say transparent is a better word, you can say, you could see what is going inside your body, isn't it? But that is abstracted. The creator has abstracted that, right? Why? We'll see why it is done. See, uh, if let's say your skin was transparent, you could see what is going inside you. So if something goes wrong, you would try to repair it yourself and end it, end up in just blowing up everything, right? Ripping yourself up and blood everywhere, your organs floating on the floor, jumping here and there, your heart and all, everything will be out in no minutes, right? So that is abstracted, hidden from you. And interestingly, if imagine you were transparent, people could see inside you. You cannot even say something like my heart beats for you because the person will say it is already beating. So why are you saying that it beats? So interestingly, you can't see inside what is happening inside your body also, right? So this is something very, very interesting. I'm just relating it with human body so that you can easily understand the concept of abstraction. But let us look at some more examples like smartphone. Now we have smartphones everywhere these days. People have more than one also. So function The function of a smartphone is to call, send messages, take photograph, access the internet. Now imagine the internal component, that is processor, memory, camera, and all, and the software, that is the operating system your app has. It is all encapsulated within the phone's outer casting. So it is not shown to you, it is hidden, abstracted from you. So in this scenario, the outer casting, now let us relate with the code also. So the outer casting of a smartphone acts as a class, encapsulating all the internal components and software within it, right? The internal components and softwares are private data members of the smartphone. We have seen private and public data members. So we can now understand the concept. Now, functionalities like making calls, sending messages, taking photographs are the public methods that provide a controlled interface to interact with the smartphone. Okay, so the users use the smartphone functionality, that is public methods, without worrying about how the internal components, that is the private data members, work or the methods work. They don't have access to the internal components directly, ensuring that the data protection and maintaining the integrity of the phone's functioning. Okay, so your methods are abstracted from you. What is going inside, you don't know. You are just using the applications which are installed on your smartphones. You don't know what is going behind that because it is not required, abstracted from you. Okay, now let's talk about a coffee machine. Okay, now imagine a coffee machine which is another object of your daily life. Could be for some. The coffee machine has button for different type of coffee, water tank, bean holder, and so on. Now, the working mechanism of the coffee machine is hidden inside its outer structure. The scenario, that is, the outer structure of the coffee machine, acts as the class, which abstracts all the working components and mechanisms, right? The water tank, coffee bean holder, all are private data members of the coffee machine class. The button to select different type of coffee are the public methods that provide a controlled interface to operate the coffee machine. So users can select the type of coffee they want. That is the public method they can use without directly accessing or manipulating the internal components, that is the private data members, beans and all, milk, beans, water. We don't have to access that of the coffee machine. This encapsulation or abstraction as a whole, it ensures that users can interact with the coffee machine in a user-friendly and safe manner without having to worry about its internal complexities. See, so you can see that in both the cases, encapsulation and abstraction, how the private members, data members are encapsulated, and how the entire class is abstracted from the users. Okay, now let's go to the another one, and we can say that abstraction holds significance in object-oriented programming. It is a very, very important part of OOPS. What it provides, it actually enables the management of the complexities. So by employing abstraction, you can say a program can organize classes in a hierarchical manner, which helps in simplifying the structural components or the structuring of the code. That is what is the main idea behind object-oriented programming, object-oriented designing. This hierarchical arrangement allows for the creation of higher level classes that inherit properties and behavior from lower level classes. We have seen the classes, all type of classes we have discussed in the previous lectures. You can have a look at it if you have forgotten, or if you have missed, or if you have not noted. Noting things is important. Make notes so that you can learn faster. So promoting code reusability and modular design is the aim of abstraction, or you can say as a whole of object-oriented programming. So by definition, we can say that abstraction can be defined as a concept of hiding unnecessary details and represents only the very essential components, right? So whatever is important, only that is to be seen. Others are not seen or not required to be shown. Okay. So implementation is also important. We have to look at the implementation. We will be seeing that through examples. And here a new keyword will be coming, that is interface, and I'll be talking about interface also. But as for implementing abstraction, abstract keyword is used with a class and a method. We can use abstract keyword or interface. Okay, and we have polymorphism, inheritance, they all encapsulation, they all help in protecting the code or abstracting the code, right? So whatever the behavior of your code is, you just want to abstract that from the users, you can do that. And how we do that, we'll see it through examples. Let us look at this example. This is a very simple example. Here we are just declaring two classes A and B, which is A is abstract, the keyword abstract is used. You can see that, and that is what I was telling you. We have to use the keyword abstract or interface. Okay, we'll be talking about that also. The abstract keyword is used here, and class A is declared. Now we have variables x and 10 is equal to 10, y is equal to 20. Then what happens now? Class B extends A. Okay, that is what it is inheriting A, right? So it is inheriting this class, and this way we can implement abstraction. And we'll look at the main code. So in the main code, what we are doing, we are creating an object of class B and implementing that. So we will be looking at the code also. So let us look at the code first, and then we will be talking about this in detail also. Okay. Okay. Now this is the code which we were looking at. So in this code, we have abstract class A. So an abstract class is a class, you know, that cannot be instantiated directly. We cannot create an object of this directly. That means an object cannot be created, right? So it is designed to be blueprint for its subclass, right? So defining a common interface and structure that subclass must implement. So in Java, you declare an abstract class using abstract keyword. That is what we have done. Abstract class A. So in this case, in our example, A is declared as abstract with integer variables x and y. And since A is abstract, you cannot create an instance of A. That means you cannot create an object. Okay, new A, you cannot give that. But you can create a subclass of A. Okay, subclasses of, right? You can create subclasses of A. Now look at subclass B. So what is B? B is a subclass that extend abstract class A. Subclasses must implement all abstract methods from their abstract parent class. However, in this case, there are no abstract methods in class A, so B is not required to implement any method. We'll be looking at this in the next example, where we will create an abstract method also. In this case, we have just public void add, and we are just simply printing x plus y in B. In x and y, they come from A. So class B has a method called add that simply prints the sum of the variables x and y inherited from class A. Now, look at the main class, that is my abstract. Okay, so let's look at this one, my abstract. What we have here, only main, and we are creating an object of B and calling the method add. That is the simplest example we have. So when we run this, we can run this, we can either compile or run. Sometimes, although this is not an interfaces can give some errors, but here I think it should not have any issues, right? Right. So x plus y, that is 50. 50 is there, and the output you can see that 50 is there. Right? Okay. So now let us look at another example where we can have abstract method also. Right? So we'll have a look at the second example. We have a class shape. Right? Class shape. There are a lot of comments I have put. And then we have a method that is calculate area, which is actually abstract. Okay. Now, this has just a method display. This is a shape and nothing else. And this method is only declared. You can see that, right? So the shape class is an abstract class which serves as a blueprint as in the previous case also. It has an abstract method which I told you, calculate area, and a concrete method display. Simple method or concrete method. We have looked at concrete classes and methods in the previous lectures. The calculate area method is declared abstract without implementation. There is no implementation there. There is no code there, and is intended to be implemented in its subclass. While display method is implemented in the abstract class itself. So we have seen this. Now let us look at the subclass, that is your concrete class, that is your circle. Now circle extends shape, right? So there are two subclasses here. One is circle and one is rectangle. We are having two here, circle and we have rectangle also. Both extend shape, right? And we have here radius. Radius will be passed on. Then we have a method circle, which will be storing radius here. Then we have a calculate area, math.py. We are calling math function here. Math.py is called, and the radius we are multiplying this with radius. Okay. So math.py, that is a module we are calling. And then we have the rectangle which extends shape again, and we have double length width rectangle method, which is again this is a constructor which is storing the length and width, same way as in this case we had a constructor here also, that is circle, not method. Circle and rectangle both are constructors here. And then we have calculate area, which is a method to calculate the area of the rectangle. Okay. Now this is the main class, and in main class we have two objects created. One is for circle, the other one is for rectangle. In circle we are passing the radius, in rectangle we are just passing the length and the width, and we are just calling it and printing. So shape dot calculate, shape2 dot calculate, these are the objects. Calculate area is the same method, and we are simply displaying. Display is, you can see, is there also. We have display method. This is a shape, just to display. This is a shape, nothing else is displayed. We are not displaying anything else, so we are just displaying here. But the area of a circle and area of rectangle is displayed using this calculate area function, because it has this, it is just returning it. Okay, so it will definitely display because it is in system.out.println. Now suppose if I run it, let us see. Now you can see area of the circle 78.59, of rectangle is 24. This is a shape, this is a shape. If I just want to change that a little bit so that it is the output looks cleaner, I can put it like this also. Okay, so now we have the area and then the message that this is a shape. Then we have the area of the rectangle and then the message that this is a shape, and this is being called from abstract. Okay, but if I want to create an object of abstract method here, I cannot do that. If I want to create an object of shape, I will not be able to do that in my main. Okay, it has to be inherited, it has to be extended. We have to use extend keyword to get it. Okay, so this is in this example. Now, okay, let us look at interface first, and then we'll be talking about other things. So, implementation, we have seen, we have abstract class, abstract method, and there is something now new, a keyword which has come, and we'll be looking at the example of interface. But before that, let me first of all tell you what interface is all about. Okay, so interface is actually a type of abstract class only. It can only contain abstract method and constant fields, that is static and final variables. It defines a contract that class says implementing the interface must follow. specifying a set of methods that the implementation classes must provide. So it is only for the declaration, nothing else. So interfaces, we declare the methods or the variables with particular values, but nothing else is declared in this. Okay. So like implementation calculations, we don't do in interfaces. So let us look at an example and understand it further. We have here an interface. Okay, here. Interface is drawable. Okay, that is you can draw. And you have method, abstract method, that is void draw and resize. Again, these are abstract methods. Interfaces also cannot be, you cannot create an object of this, that is, you cannot instantiate them. So they are abstract methods only. And their type of abstract method, that is what I told you. Now, circle, that is the base class, implements drawable. Okay, so circle implements drawable, and we have the private members here, double and radius, that is double radius. Then we have a circle constructor as in the previous case. We are just putting the radius there, and then we have a draw method which actually calculates the radius and displays. Actually nothing else is done here, only we are just drawing the radius, we are just displaying the radius. Then we have a resize method which resizes the circle to width and height when we are passing to it. Okay, that is which is to be passed. And then we have another one, that is rectangle. Same thing we are doing with this also. It implements drawable, that is it is calling two methods, draw and resize. Okay, it is inheriting that. Draw and resize again. Draw is displaying the width and the height, and resize again the new width and height which we will be passing to it. Nothing else is done here because we are neither incrementing or doing anything. It's just for the sake of example. So we have an interface now instead of abstract. So the keyword has changed to interface now, and drawable is the method. Then we have a circle and rectangle as the subclasses which implements drawable. Here the keyword extends is replaced by implements. Okay, so we have implements and we are now inheriting that using implements. Okay, so interface we are implementing, and now in the main, let us look at the main method. So main method, we are creating an object of circle and object of rectangle. Circle and rectangle are objects to circle and rectangle classes, that is the subclasses. Now we have drawable, that is drawable 1 and drawable 2. We have circle, that is polymorphism behavior is called here, drawable 1 and drawable 2. Drawable, that is drawable 1 and drawable 2. We are doing it here, circle and rectangle. Now drawable 1 dot draw, drawable 1 dot resize, then draw and resize. Polymorphism behavior is implemented here, treating object as their interface type. Okay, so this is an object only. Okay, we are just putting an object to it. We are not creating an object of drawable. Okay, we are not creating an object, we are just passing on the objects to it. So we can treat that like this also. Now drawable to draw, resize, then we are again calling 1 and 2. They are two objects and we are just calling them, and we are implementing interface here. So you can see it doesn't work like this. So let me compile it, and then you can see that it will run without any issues. So from VS Code, if I try to directly call it, it may not work in some cases, and in this case it is not working. So what I have done is I have compiled it on the command prompt, on the terminal prompt you can say, and then run it, and it runs fine because there's nothing wrong with the code. So circle it is called, and you can see that we have the output here, right? So this is interface, and interface is a kind of abstract method only, right? Okay, so now I think this should clear everything you have in your mind, and we'll be looking at more examples, more implementation in the future lectures. And to understand the concepts better, these are the basics actually we are covering, but we will have more lectures on this to understand how practically we implement the concepts and how the design is done. Object oriented designing is also important. We'll be looking at it in the future lectures, in the coming lectures. We'll be looking at that. Okay, so next lecture will be on data hiding and information security. Although we have actually done encapsulation and abstraction, it is sort of hiding and information security is similar to that, but we will see it separately and see how the things are implemented and done. Okay, so just keep in mind the four pillars are very, very important part of object oriented programming. We have encapsulation, polymorphism, inheritance, and abstraction. These are the four big pillars of object oriented programming. The entire structure depends on this. We'll be looking at the design definitely, but for now, just remember this, right? And we will I'll be looking for you in the next video lecture. Till then, keep learning, keep enjoying, and keep noting. Okay, so whatever doubts and all you have, just note them down, have a look at the lectures again, and see if you can resolve them or not. Okay, till then, have a nice day, enjoy the lectures.